Hello everyone. In this video we are going to see Fibonacci series printing using recursion. What is a Fibonacci series? The numbers you are seeing here, the series is called Fibonacci series. What is the series logic? Every term in this series is a summation of previous two items in the series. Say every item in the series is the summation of previous two items. Say for example, if you take 21, which is an item here, it's a summation of previous two items, which are 8 and 13. If you take 233, which is one of the item in the series, it's a summation of 89 and 144. So every item in the series is a summation of previous two items. So if you take 377, it's a summation of 233 and 144. If you take 8, it's a summation of 5 and 3, leaving out first two items. First item is 0, second item is 1. So this logic applies from this place onwards. So for this third item, summation of second item and first item. So this is the logic of Fibonacci series. Finding nth item in the series. If I want to find nth item, say for example, I want to find 10th term in the series. We need the 9th term and 8th term. Then we can do a summation. See, the 10th term is 34. To get 34, which is a 10th term, I need the 9th term, which is 21, and then I need the 8th term, which is 13. So if I have 9th term and 8th term, I can get 10th term. So this is the basis for finding the subproblem. So here recursion needs to find the subproblem. So if you need the nth item, I need n-1th item and I need n-2th item, then I can do a summation. So if we are writing a function which finds the nth term, then we need the n-1th term and n-2nd term. So function n will be just giving rise to subproblem, which is n-1. So to find n, the function will be using n-1 and n-2 as arguments. So this is the subproblem. So now the problem size will be reduced. So here function n, function which finds nth term, will need the n-1 term and n-2th term. So this function will wait for these two functions. So again this function will be needing for n-1, n-2. When this function got the value and when this function got the value, these two will be summed up and then this will get the value. So now the problem size is reduced. How it is reduced? We were looking for finding nth term. Now to find the nth term, we need n-1th term and n-2nd term. So now the problem size is reduced. Say for example, if I need to find the 10th term, I need the 9th and 8th. I need the 9th and 8th. 10th term finding needs 9th and 8th term. So now I don't worry about finding 10th term. We worry about finding 9th term and 8th term. So the number got reduced. So the 9th term will need 8th and 7th. 8th term will need 7th and 6th. Likewise, numbers goes on reducing. The problem size goes on reducing. Say for example, n-1 needs n-2nd term and n-3rd term. Then we can sum up. So the n-1 is the actual problem size. Now this problem needs n-2 and n-3. The problem size is reduced. So this goes on getting reduced and reduced. So obviously we need a stopping criteria. What is the stopping criteria? If you are finding f of x, this is kind of x. So if x is the nth term, so here this is the nth term, okay. So if the term which is nth term, which is x here, if it is 1, that means first term. What is the first term? It will return 0 value. So first term value is 0. So if the nth term, that is x, which is equal to 1, then we are going to return 0. If the nth term, which is x, if it is equal to second, if it is second item, we are going to return 1. So for the first item we're going to return 0, for the second item we're going to return 1. From the third item onwards we'll be doing the summation. Third item needs second item and first item. Fourth item needs third item and the second item. This is the fifth item. This needs fourth item and third item. But if you come to first item finding, we don't go this logic. It will just return. Stop it. If you're coming for first item finding, it won't go to the previous finding. You are stopping. So this is the stopping condition of the recursion. I'll write a code and show it to you. So first we'll just print 15 items in the series. So for I in range, I want to print 15 items. First 15 items in the series we are printing. So I'm just calling print. We just have to generate. So I'm going to write a function which can generate the term generator. I just say it will get which term, nth term. Likewise it will get the term generator. So here I'll pass this I to the term generator. So if I pass 1 here, when I points to 1, I am passing to the term generator function, get me the first item in the series. If I is 2, get me the second item in the series. If I is 7, get me the seventh item in the series. So if I is 7, for example, it should return. What it should return? It should just get the term in generation. It will ask. If you are passing n, that is 7 in the case, for example, it will ask 6. Okay, 6 is nothing but n minus 1. Then it will ask 5, which is n minus 2. So term gen n minus 2. So if you are passing here 7 goes here. So n minus 1 is 6. So it is a recursive function call. Function calling itself 6, then it is 5. So first this function will start. So the return cannot return anything because it has to finish this left side of the plus sign, which is a binary operator. So this function call will happen. Till then the n will wait. So n minus 1 call happened. So when you are asking for 7 is originating 6 function call, and the 6 returns, it will originate again a function call with the value of 5. 7 minus 2, 5. When both returns, then 7 will get the left side value of this plus and the right side value of this plus. Then it will return the summed up value to the place of asking here. So till then it recursively goes. So what is the stopping condition we are seeing? Stopping condition is if the value of x is 1 or 2, that means value of n we are passing first item or second item. So if first item, if n is equal to 1, then what are you returning? Return 0. Okay. If n is equal to 2, then you are returning 1. Otherwise it will return here. Otherwise it will go here. So first, if n equal to 1, it will return 0. You can put it in elif. That's a nice way to do. Elif. So if n is not equal to 1 or 2, which is a stopping condition here. If it is n equal to 1, return 0. We have put it here. If n equal to 2, we are returning 1. If n equal to 2, we are returning 1. If it is not that case, it will go to this part by default. There is no need for else. Here you can put else also. You can here put it here. So it will just call if for the more than these values. So in case of say for example, if I am trying to print 5 numbers, say 5 means 4 up to 4, 1 2 3 4, 1 2 3. So first we are calling 1 is called. Let us just go through this. 1 is called. How it will print? Term gen passing 1, n equal to 1, so it returns 0, so it prints 0. Okay, so 0 is printed. I'll just introduce a comma here. So n will just put a comma here. So after that it prints a comma. Then I point to 2. So when n equal to 2, what happens? It returns 1. So the 1 comes to this point. That means 1 is printed. Then come on. Okay. Then I is 2. Sorry, I is 3. When I is 3, it goes here. N is 3, but n is not equal to 1, not equal to 2. Okay, it is 3. That means it is going here. N minus 1. What is n minus 1? 3 minus 1 is 2. 3 minus 1 is 2. So the call happens. The 3 minus 1 is 2. The call happens. It is returning 1. So at this point, I will be getting 1 here. 1 will be here. Then once you got this 1 value, we are just holding. I just put a 1 here. Okay. This value. In the case of 3 calling, the 1 is obtained here. Now the call goes here. Okay, so n is 3. 3 minus 1, 2. So the 2 returned and it returns 1 here. Now the call is 3. 3 minus 2 is 1. The call goes. Okay, whatever the value you are passing is 1. That means it will go here, return 0. So in this place, I will be having 0. So 1 plus 0. What is 1 plus 0? 1 plus 0 is 1. Both values got. So that it returns. So 1 is printed. Okay. So this logic recurs now. Now what is happening? We are passing 4. Term gen, we are passing 4. We are going for 4th value getting. The 4th value, if it goes here, 4th is n minus 1. So it is 3. It goes to 3. So 3 is passed. 3 is passed. 3 goes here. The 3 goes here. 3 will need a 2 and 1. So it recurses in this fashion. So it will print the whole thing in this way. See, it returns 4 items. So if I put 16, the first 15 will be printed. The first 15 items in the series will be printed. So this is the logic for recursive Fibonacci series printing. I hope you understood. Thank you.